Okay, so in this video we'll upload today, this is going to be everything that you need to establish connection, address the two inputs that we're going to use, and activate one output. And it's going to go step by step. If you got questions, everything's getting recorded, so watch our languages and stuff like that. But if you want to ask questions, it'll make it more interactive. I'm going to upload the entire thing onto the YouTube. You need it, go back and visit it. If not, then don't worry about it. But I can email you the link, or you just go to the YouTube channel and then it has all of the other ones. Because I'd like to add a bunch of additional stuff that we don't do, like for the mechanical stuff, drilling, tapping, using the grinder, changing the disc. Just make a whole bunch of little 3-minute videos, so that way if you need them, you can go back to it real quick. That way you don't got to try to rack your brain about if you're going to be able to do it.
She didn't answer.
Oh, this come in.
Are you sure?
I may regret it later, but yeah.
Well, I mean, I'll take pictures and I'll come back tomorrow if she gets a hold of me.
Well, I just don't want to. No, I don't want you to miss out, but I don't know what they're going to say. And then if all of a sudden if they say no, then.
But I mean, she came back negative. Everybody came back negative.
Oh, so. She came back negative too.
So.
Oh, then if you're all negative, then you should be fine.
All right. So you want me to wait? I mean, I can come back tomorrow.
No, if you guys are all good, don't worry about it.
Are you sure?
Yeah, that's cool. Isn't that everyone's happy and healthy? Let's do it. All right. So you get all your program. You open up the computer. You sign on. The password for our computers is password. So you type it in, and then you come over. You got to make sure that the cable is connected. So the cable that we use is the RS232DF1, and it plugs into the PLC, and then it plugs in down here to your computer.
What cable is that again?
RS232DF1. And I also got, like, those are the instructions right there. That's a step-by-step set of instructions. And there's more of them on the file cabinet. So if the video don't do it, you could literally grab one of the white papers, and it's written down step by step. Click here, click here. So that's our cable. Yeah, we can show that to it. We'll just let this whole thing ride while we're doing this. That way it's nothing. So that's the cable, or that's the paper you're going to look for, if you need that one. Okay, we've got our PLC wired, plugged in, energized, everything's going the way we had it from the previous video. So you come over on the computer and you click on the RS links, double click on it, and it'll open up the program. Opens up RS links, we come up here to communications, we click, and then you go down to configure drivers. You click there. Available driver types, that's our cable. So you click the drop down menu, RS232DF1, that's our cable we're using. Add new. You can rename it if you want. I don't, because it's always going to be changing, or for each person. Click OK. Now you have to figure out which communication port, the COM port, which one's plugged into the computer. Typically on the laptops that we use, it's between 3 to 7 or so, 3 to 8. And I just happen to know this one is 8 on this one. So you come over here to COM port, and I'll show you if you get the wrong one first. Let's say you pick number 2, and you click Auto Configure. Unable to open the specified COM port for configuration testing. Okay, so then you want to do another one. If you want to check it at 3, click 3. Unable to open. Okay, like I said, I know this one's it's 8 because this is the computer we used last. Come down, click 8. Auto configure. And it tells you auto configuration successful.
So what were you doing right there?
That's establishing connection with the RS links. So then we're going to click OK. Close, close. Now that part's done. Go to micrologix, double click on it. I'm going to maximize it so I can see a little bit better. You click on File, New. On the side of our PLC, because we're using a micrologix 1100 Series B, and it's literally got a sticker on the side of it that says micrologix 1100 Series B. We click OK. And then now you've got the program opened up. Now, this is your first rung. It's the end rung. That's the last thing that's going to occur. We're going to write a simple stop-start with the memory circuit. So that'll get you through just the basics of addressing, going off of the wiring you previously did, and then writing a simple program. We'll download it, and it will execute it, and then that way you can see everything. First start. Under the Users tab, there is a new rung. So we can click that and drag it down to where the little, now it's got a little green X right there. Drop it, and I'm going to zoom this one in for you guys that are in class. Right there. That's going to be the first rung that we're going to put some of our information in. Now, the trick is, you remember, you're trying to write a true statement. It's got to be true from, so you'll have little green dots highlighting everything all the way across if it's true. So, we always start with our stop. Our stop happens to have the normally closed set of contacts. So when you look at the PLC, you see that it's already got the input coming in, because you got 120 coming into the button, going out of the button into the input of the PLC. So because it's detecting that input like it's going to be true, I'm going to use an open set of contacts, and I have to address it with that address. Because it's an input, it starts with an I, so you type I, and then you have to hit colon. Now, we have a fixed PLC. It's not modular. There's no slots. So since there's no slots, it's 0, I:0, slash, and then it's which screw did you take that wire to? And according to what we did, and on the PLC it even highlights it, it's at 0. So I:0/0 is going to be the address for the stop button. Oops. Hit enter, and then this is going to be our stop. So now we put the description. Well, because it's going to have because we're utilizing a closed set and the signals go into the PLC, it's going to say, hey, if this was an open set, someone must be pushing the button. That would be a true statement. Now, I got to go grab for the start button. I grab the start and open set of contacts, and we drag it down. It goes back to the address again. So the address for the start goes up to the 1 screw. Therefore, the address I:0/1. And then you go to start. Okay. Well, we got to turn on an output. That's the whole goal of what we're trying to do. So, still under the user tab, it's the 1, 2, 3, 4, 5th icon over. And it's for an output, or turn on a bit, it says at the very bottom. You drag it over, and what are you turning on? We have our lights are hooked up to the PLC. Which light? It depends on where you're going to take the address from. So I will use the output O:0, because there's no slots, /0. Type it in, O for output, :0/0. And I don't remember which one it is, so I'm just going to call it light. Okay. Now, with what we've got on the projector, we don't have the memory circuit. So we do this the same way that we were practicing from last year. You're going to go down and get a branch. Up here, the second tab over under the second item over under the users tab, it tells you place a branch in a rung. You click it. And then because we want it in parallel with the start for a memory circuit, we drag it around. What are we trying to latch on? The output. So we need an open set of contacts in parallel with the start button to serve as the memory. You go get yourself an open set of contacts. you drop them down, and then you address it. Since it's for this light, it's O:0/0. Enter. And that's the light. So now we've got our stop, start, our output, and our memory circuit. So let's say we want to make sure that we don't have no mistakes in our addressing what we type. A big thing, people make the O and the 0, they get those mixed up. So sometimes people will put O:0/O. It's O:0/0.
If you add another light, would you add like a 0, 1 and 0, 2 on the input?
It would be whatever the wire that's going to service your output wherever it's terminated. So for example, the next light is terminated at the 1 screw. So it would be O:0 because we have no slots /1.
And that would keep on going to the next light.
To whatever you're going to go to. So whatever you have hooked up to that address is what's going to be turning on, what you're referencing. So let's say we got all of our stuff in there. We come over here and there's a verify file or verify the program. You click it and then it tells you down here, verify as completed, no errors found. If you made an error, let's put an error in here just so you can see it. I'm going to go back to that output and I'm going to change it. Remember I told you a big common mistake is O:0/O. Watch this. O:0/O. Enter. See how it gives you all the little E's and everything? And then when you come up to click verify program, it tells you invalid direct file offset on rung 0. So you click it and you're like, okay, it's highlighted. This is where I got an issue. I come back into it. I go O:0/0. Enter. Verify. Now you're good. Okay, so this is just a very basic program, and then you can always fine tune it to whatever you want it to be. We're using the output for a light. If you wanted a motor starter, then the wire wouldn't go to the motor, or wouldn't go to light, it would go to the motor starter. If you want it to turn on a buzzer, then it needs to go it's whatever you're turning on. That's what you're addressing that output to. So it's got to be exactly right. Now, you've got no errors. You come over here, where on the tab that has offline, you click it, and then you go down to download. Click it, and you can title it. So we'll say, we'll just call this the demo. If you want, you don't have to. Download the program, yes. Processor is in remote run mode. Processor must be switched. Continue, yes. Change back to run, yes. Do you want to go online? Yes. Now, see how the green light's already right here? Because it's getting the input, and it's the same thing on the PLC. It shows you on the indicator screen what's receiving the signal and what's going to be fired on the outputs. So right now, we know that this one's it's getting the signal because it's going through a closed set of contacts. So now when I come and push the start button, I pushed the start button, fired the output sealed the memory circuit. So now you have power continuity from L1 to L2 through the use of our programming and the way we've got it set up. When you want to go push stop, simply push the button. You'll see that this will lose the green. Everything's off. I'm going to let my thumb off the stop. It goes back to green because it's getting the input back in the PLC. I'll hold the start button so you can see it'll be green here. As soon as this turns green, that turns green, and that turns green all at the same time because it's a true statement from left to right. So push the green button. There it goes. So it's green, 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 green. I take my finger off. Now it's green, clear, because it's not getting the input into the PLC. Programming, got the output fired. Now you've sealed your memory going down and around. This video we're doing right now is specifically to establish communication write an address, download it to the program, verify the files. Do you have a question as it pertains to going through just establish the connection, write a simple program, download it, execute it? Because the next one we're going to do, we're going to add the timers and we're going to do the counters. Okay, so we'll cut the filament on this, we'll upload it to the YouTube, and then we'll start making another one. So is that okay for everybody?
Yeah.
All right, so you got it cut off?